Now we are going to do the topic of graphs and gradients. You know very well when we talk about graphs and gradients, we simply mean the slope, which is the change in y and change in x. Now, by the definition, many times you want to pass a problem in mathematics, or definitely to understand it, you have to go back to the root definition, knowing very well that if I give you y is equal to mx plus c, you must know the meaning of the c, the x, the m, and the y. Remember, the x and y are variables. Variables means they take different values of the numbers. But x, m, and c are constants. An example, if I draw for you having the x and having the y-axis, remember sometimes in the textbooks, instead of writing y, we usually take y to be a function of x. Especially those people are now in year 10. They need to know that whenever we take y as a function of x. Now if you draw a line of that nature, where that line is cutting y, we call it the y-intercept. Where it is cutting x is called intercept, x-intercept. But remember, at y-intercept, the value of x equal to 0. And at x-intercept, the value of y is equal to 0. Now, the first thing you need to understand is to interpret this given equation, y equal to mx plus c. Remember, m is called the gradient. M is the gradient. And what do we mean by the gradient? The change in y by change in x. Now, if we come here, this is the change in the y-axis. This is the lower part is the change in x, right? So instead of writing this, you can always as well write it to be y1 minus y2 over x1 minus x2. Remember, in an exam, we are not interested only in the answers. In fact, if you write only the answers, you fail. You have to show every step. You begin by what? By the definition of the particular concept. Then you show us how you go about it. An example, somebody may come and put, what if this point where it cut x is 4, where it is cutting y here, make it to be 10. So you have to read the coordinates. Call this one maybe A and call this one B. So if you have your point A here, remember we normally start with the x, then we go to y. Your x at y-intercept is 0, and your y there is now 10. Then you go to your next point B, where it cuts x is supposed to be 4, and y at any x-intercept is 0. So you may decide the first pair to stand for the x, then y. Then going back by the definition, changing y by changing x, giving you the gradient. So what am I supposed to do? You may start from the top, 10 minus 0 over 0 minus 4. So anytime 10 minus 0, you get 10, then you get negative 4, which simplifies to be negative 2.25 to be the gradient of that line. So it's important to know it from the definition. Then there are some other basics, because this is just a general revision. Somebody may come and give you point P to be maybe 2, 4. Then they give you point Q maybe to be 6 and 5. Then they ask you, find the gradient of line, find the gradient of line PQ. Find the gradient of line, this means line PQ. So you just identify, you can call it x1, y1, then you call it x2, y2. Then you go back to the definition, then you will start maybe here having your 4 minus what? Minus 5 over this 2 minus 6. Remember, whenever you take a smaller number minus a bigger number, you get a negative. So we get negative 1. 2 minus 6 is negative 4. Remember, the negative cancels out. So we are going to get it to be quarter. So 1 over 4 will be the gradient of that line. But you need to always go back to the what? To the definition of that. Now, I also want to explain some other concepts. If you had this particular line, remember what you are taught also in trigonometry. you learned something about SOHCAHTOA. And I want to connect it to what we do in gradients and see how is the angle in a line related to the gradient of the given line. Now, if here is y and here is given to be x, and you have a line of that nature, remember, if the angle here is given theta, following the trigonometric ratios, we always know that tan of an angle theta is equal to opposite over adjacent. Now, if your angle here is theta, the opposite to this theta is this side, and the adjacent to this theta is this side. Remember, the opposite is the change in y, and the adjacent is the change in x. So it implies change in y by change in x becomes opposite over adjacent, which basically speaking is equal to, this was supposed to be the gradient, because change in y by change in x is gradient. And it is still the same as opposite over adjacent. So this is a very important connection, that gradient is the same as opposite over adjacent. But what do you see to be opposite over adjacent? If we wrap this part, the opposite over the adjacent at this point is supposed to be tan theta. So anytime you see the tan of the angle provides the gradient. So in that case, somebody may decide and give you, if they give you that y is 4x plus 13, then they ask you what is the angle that line makes with the x-axis. It's very simple. We already know by the definition that the tan of the angle theta provides the gradient. So we come and write that the tan of that theta, which we don't know, is supposed to be what? Is supposed to be 4. Okay? Now we want now to change it. We want now to make it. Now how do we find theta? We take the arctan. We take the tan inverse of 4, which from the calculator and the table becomes 75.96 degrees. So we get the arctan of that particular angle to get that. So from today, the summation that you have learned, how the two are connected, which is very important. You need to know that whenever you want to get the gradient, change in y by change in x, which is also opposite over adjacent. And remember, opposite over adjacent trigonometrically is supposed to be tan of theta. So what connection do we learn? That whenever we get the tan of theta, we get the gradient. So these are very important law. These are rules that you need to remember. That the tan of that angle provide the gradient. Because the next time what they will do in an exam, they will just draw for you a line like that. They will tell you that is y, that is x. Then somebody will draw a line like that. Then they say the angle here is 47 degrees. Then they ask you, what is the gradient of this line? You will simply come according to the rule and says, it is the tan of the given what? Of the given angle in degrees. So the moment you get the tan of the angle, you will simply arrive at your gradient of that particular line. So the most important concept I want you to note, that whenever we take the tan of the given angle, is always equated to be the gradient of that line. Okay? So I want us to also learn something about parallel lines and perpendicular line. What do we know about the two lines when we say it is parallel and we also talk about the perpendicular? An example here is, if I give you a line y is 2x minus 1, and I give you line y is negative a half x minus 13. I will just summarize it, because the two lines can only be perpendicular if the product of their gradients becomes negative 1. An example, if this is your line 1, call it y1. This is your line 2, call it y2. So if I take the gradient of the line 1 times the gradient of the line 2, I must get negative 1. Or either using the m1 times m2 becoming negative 1, which we can test from the numbers given. If you pick 2, you multiply by negative a half, you will simply get negative 1. So we justify that line 1 is perpendicular to line 2. So whenever you work out such equations, we go back to the definition that what makes two lines to be perpendicular. When we multiply their gradients, we must get negative 1. That's very important. Another one, maybe somebody gives you y is a third x minus 10, then y is maybe 3x plus 4. If you go back to the definition which you had been given here, that whenever you take the product of the two gradients giving you negative 1, then they are perpendicular. Can we try here? We take our 1 over 3 times 3, you get 1. It is not perpendicular because it is not a negative 1. It is just a 1. So that is the justification between two lines that are perpendicular. When we talk about the parallel lines, an example, somebody giving you y is maybe 13x minus 9, y is 13x minus 4. What we need to check to prove that two lines are parallel is by checking their gradients. If this is your line 1 and this is your line 2, the gradient of the first line must be equal to the gradient of the second line in order for the two lines to be parallel. But if you check 13 is not equal to, yes, 13 is equal to 13 in this case, sorry. So if you check here, the gradient here is 13 and the gradient here is 13. So the two lines are parallel. So you can write mathematically line 1 is parallel to line 2. And the rule is very simple. They can only be parallel when the two gradients are the same. So I've shown you how the angle relates to the gradient, how the perpendicular lines relates, and finally, how the parallel lines also what they have in common. Now let us try this question, the application question in this topic. Somebody can come and ask you, these are now application questions, that line y is equal to 5x plus 16, right, is perpendicular to another line called line 2. Assume this y1, this is line 1. It is perpendicular to line 2, and line 2 passes through the coordinates 4 and 7. Then they ask you, find the equation of line 2. And I repeat, if they give you a line, then they tell you that line is perpendicular to another line whose equation is not known. As long as they have provided with you the one pair of the coordinates of where that perpendicular line passes, you can be able to find the equation of that line. In what way? If line 1 here will be perpendicular to line 2, what did we say? We said and agreed that the gradients must be multiplied to equal negative 1. So this implies the m1 times m2 becomes negative 1. So we identify our line 1 as a gradient of 5. Our line 2 we do not know. So you can let it just be m2. But remember, when you take 5 times m2, you should get negative 1. Then we go back to the algebra. Your m2 becomes negative 1 over 5 because this is a product. So we divide to get m2. The moment you've identified your gradient for the line 2, now the gradient, you know it is negative 1 over 5, but it is passing through 4 and 7. But go back to the basics. What did we say? That gradient should be change in y by change in x, which implies if I have this to be x and y, so change in y here, which can be 7 minus y, over change in x, which can be 4 minus x, should provide you with that particular gradient, which is minus 1 over 5. Here we can cross multiply like that. Then you take 5 times 7 minus y equals minus 1 into 4 minus x. Then you open the bracket. Here we get 35 minus 5y. Remember, when you say 5 times minus y, you get minus 5y becomes minus 4. Remember, when a negative opens up a bracket, it changes it to be a positive. So we get plus x. Then at this stage, we can collect the like terms. We are going, let me transfer it here. So if we have 35 minus 5y is supposed to be 4 plus x minus 4 plus x. So I will only remain with the y. So I will have my minus 5y equals, here is plus x. It was minus 4. When we have it a plus and an equal sign, we go to subtractive inverse. We minus 35 both sides. Minus 35. So minus 5y becomes plus x minus 39. Then we can divide throughout by minus 5. So minus 5 will go. Our y becomes minus 1 over 5x. Negative goes plus 39 over 5. So this is the equation of our line 2. Remember, we were not given its gradient. So we got its gradient by going back to the definition. So the best way you can always pass mathematics, don't just read a question and start working it out. Make sure you understand the basics. What is the definition? Like here, we knew very well that whenever we get the product of the two gradients, if we get -1, then they are perpendicular. By knowing the first gradient, you can get the second gradient by formulating your own equation and getting it here. The moment you have the gradient, and at least where the points it was passing, we go back to the formula of getting the gradient. We will change in y by change in x. Based on my experience of marking even the Cambridge exams and students' work, we realize that many students, they don't really show the steps. They lose so many marks because of the steps. Make sure that you show the step. Even if you're not going to get it right, remember there is a method mark. We normally give the method mark. We give them M mark. And there is no way you can get the answer if the method is wrong. I've had so many students in the past complaining, teacher, I didn't get it right, though I have written the answer. The question is not about the answer. You have to show the processes. So you have to go back to basics. You must go back to definitions. In whichever topic, whatever question. So this one goes across to all the students in the globe. Make sure that you show every step in order to pass your maths exams. Whether it's a middle school, people doing checkpoint in year 6, people doing checkpoint in year 9, the IGCSE year 11, A-levels year 13, all the way to the Cambridge, to the university, make sure that you show the steps. It's only maybe in year 6 where they do the checkpoint, they really mark the answers. But that is not the real case because they expect you to show your workings before you get your answer. So from today, and the other thing that I would remind you, just writing a formula is not a method. Let me make it very clear to you. If you come and write an example, a y is equal to mx plus 7, then somebody asks you, what is the value of y, maybe when m was 3 and x was 10. By writing just the formula, you don't get the mark. But by substituting the right values in that formula, so we normally call it what? We call it a method mark. That's how we can pass our exams.